This is the proposed boarding house for Curro-Durbanville High School, situated against the Botmiscop Mountains in the Cape Winelands. This specific architectural concept serves as a direct response to a persistent problem in the premium education market. For decades, the standard real estate math for student housing was simple. Developers maximized their financial yield by packing the absolute maximum number of beds into the minimum possible square footage. The physical result of that math is the traditional dormitory. You know the layout. Long, highly institutional corridors lined with deeply compressed bedrooms, all funneling into a few shared ablution blocks. But the modern premium market has shifted. Parents paying top-tier tuition and the students themselves outright reject this outdated, stinky hostel model. If a developer builds one of these high-density facilities today, they risk creating a stranded asset. You cannot justify upper quartile market fees for a product that feels like a 19th century institution. To capture that top-tier revenue, the design has to abandon the high-density approach entirely. The solution requires engineering a facility that carefully balances spatial pedagogy, off-grid technical resilience, and strict capital limits. The core architectural philosophy, replacing that old model, is known as the third teacher. The idea is that the building itself actively guides and participates in a learner's development. This diagram illustrates the facility's deliberate low-density capacity. Instead of hundreds of beds, the boarding house is capped at exactly 50 students, split into two highly intentional cohorts. The foundational block, accommodating grades 8 through 11, consists of 40 beds distributed across 15 rooms. These early year rooms offer generous 18 to 20 square meter layouts. They're exclusively designed as twin configurations to foster peer support and socialization during the younger grades. A critical differentiator here is the plumbing. Every single room features a private ensuite bathroom, eliminating the stigma of the shared ablution block. When a student reaches their grade 12 matric year, the spatial logic of the building changes to prepare them for early adulthood. The design shifts to a university-ready concept, an environment engineered for intense academic focus and personal independence. This is achieved through a strict 20% premium allocation, 10 single-occupancy senior studios reserved exclusively for the graduating class. This render shows a senior studio. The footprint expands to 25 square meters, featuring oversized ergonomic workstations, built-in premium cabinetry, and a personal coffee station. Moving from twin-supported rooms to single-occupancy independence creates a tangible residential progression. This distinct separation is the premium experience parents are willing to pay upper-tier fees to secure. That careful spatial planning extends out of the private rooms and into the shared spaces. The communal layout requires just as much pedagogical engineering. The overarching design mandate for these areas is strict. Strip out any lingering institutional school aesthetics and mimic the feel of a premium urban residence. The architectural heart of the building is a double-volume study and social hub designated the Collaboratory. In this render of the Collaboratory, high-end functional elements are immediately visible. The central marble kitchen island encourages casual interaction. To the left, fully glass-walled acoustic pods allow for distraction-free group work while keeping students visually connected to the main room's energy. Outside, the U-shaped layout creates a central wind-protected courtyard featuring indigenous landscaping and a fire pit, acting as a restorative environment for decompression after the academic day. By removing the harsh lighting and sterile finishes of a typical school, these boutique amenities serve as the primary marketing differentiator for acquiring and retaining students. But luxury finishes mean nothing if the building stops functioning when the grid goes down. For a premium educational facility, the baseline expectation is strictly zero academic downtime. In the Western Cape, developers face the severe threat of load shedding and rolling municipal blackouts. This technical cutaway illustrates the building's hidden, closed-loop systems engineered to defeat grid failure. The active defense mechanism is a precisely sized solar photovoltaic array paired with an internal battery storage system. This system is laser-focused on keeping critical digital learning infrastructure, study lighting, and the Wi-Fi network online 24/7. For climate control, the design team chose to abandon high-maintenance HVAC systems. Instead, the architecture utilizes a heat chimney mechanic. The central atrium is structurally designed to naturally draw hot air up and vent it out of the top of the building. When you combine that continuous passive airflow with the dense thermal mass of the off-shutter concrete walls, the residential wings naturally regulate their own temperature. These off-grid systems serve as calculated engineering moves designed to aggressively slash long-term operational expenditures. So, how does a developer deliver boutique amenities and comprehensive off-grid technology without exceeding strict corporate capital expenditure limits? The solution involves shifting away from traditional, fragmented procurement and utilizing an integrated design-build consortium to control the financial matrix from day one. A primary driver of these cost controls is the specific material innovation chosen for the structure: smart steel. In this simulation, a lightweight steel structural frame is rapidly and precisely assembled, snapping together on site without the need for heavy lifting cranes. This specific construction method generates specific financial results. It delivers a 30% reduction in structural costs and a 50% faster build schedule, which minimizes disruption to the active school campus. This dashboard outlines the resulting financial reality. Those construction efficiencies drive the final capital cost down to between 680,000 and 720,000 rand per bed. To validate that upfront investment, we look at the revenue generation. Because of the architectural product, the facility can command a true luxury tier fee of up to 155,000 rand per annum per student. When benchmarked against regional competitors like Bridge House, it shows that upper quartile pricing is achievable if the physical product supports it. At a full 50-bed occupancy, this engine generates over 7.4 million rand in annual revenue, providing a robust basis for debt service and cost recovery. The integrated design-build model and back-end construction efficiencies absorb the capital risk, making the high-end pedagogical architecture commercially viable. Zooming out to the macro perspective of modern educational real estate reveals a clear divide. Attempting to force a high-density, low-quality dormitory onto a premium market is a mathematically flawed strategy. It results in empty beds and lost yield. The Curro-Durbanville model solves this by relying on three specific pillars: spatial pedagogy that prepares students for university life, passive engineering that ensures operational resilience, and a design-build efficiency that controls capital. This concept proves that delivering a luxury architectural product and maintaining a high-yield balance sheet are not mutually exclusive when engineered as one cohesive system.